Welcome to Chemistry with Dr. Z. I'm Dr. Z, and in this video, I will be talking about the structure of the atom and the different subatomic particles. The structure of the atom, the atom model states that an atom consists of a nucleus and electrons orbiting the nucleus. First of all, we need to know about the relative electrical charges of the different subatomic particles and what are these subatomic particles. Atoms have a radius of 0.1 angstrom, and 1 angstrom is basically 1 over 10 to the power 10 of a meter. So just to try to imagine what's the angstrom. There are two things here to talk about in the atom. The first thing is the nucleus. The nucleus is found in the middle of an atom. The radius of the nucleus is 1 over 10,000 of the radius of the atom. So basically, the nucleus is very tiny compared to the total radius of the atom. It consists of two or contains two different subatomic particles, and these are the protons and the neutrons. So the protons have a relative mass of 1 and it has a relative charge of +1. So each proton has +1 charge and the relative mass is 1. We are talking here about relative mass, so this is the mass of the different subatomic particles relative to each other. And then we have also neutrons, and neutrons, the relative mass is 1 as well, and they are neutral, so they don't have any charge, so their relative charge is 0. So the nucleus as a whole is positively charged. How many positive charge are there depends on how many protons is actually there. So almost all the whole mass of the atom is concentrated in the nucleus. And then we have the electrons. So the electrons actually move around the electrons move around the nucleus in shells, which are the energy levels. And the electrons are negatively charged. So the charge of the electrons is -1. So each electron has a -1 charge. The relative mass of the electrons is very, very small, so it's almost neglected or absolutely neglected when we calculate the mass of the atom. The volume of their orbits determines the size of the atoms. So it's quite big compared to the size of the atom. So most of the atom is actually vacant spaces, and the orbits of the electrons will decide or determine the size of the atom. So looking at the number of the protons and electrons and neutrons in an atom. So for any atom, the number of protons inside the nucleus equal the number of electrons that orbit that nucleus. This is why atoms are neutral, meaning they are not positively or negatively charged because they carry the same positive and negative charge, so they are both cancel each other out. The neutrons inside the nucleus are neutral, so they do not contribute to the charge of the atom. We also know the term of ions or heard the term of ions. Ions are either positively or negatively charged. This is because the number of protons do not equal the number of electrons. So an atom can either gain or lose electron. If an atom gains electrons, then the number of electrons or of the negative charge will exceed the number of the positive charge inside an atom, and we end up with a negatively charged ion. And if an atom loses electron, then the number of electrons will be less than the number of protons inside the nucleus, and we end up with a positively charged ion. So let's move on to talk about the atomic number and mass number. So each atom is recognized by two numbers, atomic number and mass number. And usually the nuclear symbol of an atom gives both the atomic number and the mass number. So let's have an example and try to identify which is which and what do they mean. So if we have something like carbon, so carbon is 6 and 12. At the bottom here left, you can find the number 6. Number 6 refers to the atomic number. An atomic number is the number of protons in an atom. And because the number of protons equals the number of electrons, then that means that this atomic numbers refers also to the number of electron of an atom, not an ion. So the atomic number, number of proton or electrons. And then we have the mass number. So this number that is written at the top left is the mass number. So mass number is the total number of protons and neutrons inside the nucleus. In case of carbon 612, you can find that the number of neutrons and protons equal 12. And because the number of protons is 6, we can calculate how many neutrons are there by simply subtracting mass number minus atomic number. So the number of neutrons here in this case is 6. So for carbon, there are 6 protons, 6 electrons, and 12 neutrons, and 6 neutrons. So there's something called the isotopes. So different forms, isotopes are different forms of the same elements which have the same number of protons, but they have different number of neutrons. So for the same element, you might find different atoms which are of the same elements. They have a different number of neutrons. They will always have the same number of protons and electrons, but they could have different number of neutrons. Having different number of neutrons means that the mass number is now different. And these atoms are, or these different forms of an atom are called isotopes. Example of these is carbon 13 and carbon 12. And when we say carbon 13 and carbon 12, we are referring to the mass number. So in carbon 12, this one here, you're going to find the number of protons 6, number of electrons 6, and number of neutrons 6. Carbon 13, which has a mass number of 13, it has 6 protons, 6 electrons, but it has 7 neutrons. So the isotope only differ in their mass number. They only differ in the number of neutrons, not the number of protons. So in the periodic table, when you look at the periodic table, you're always going to find the atomic number and the mass number. Atomic number does not change for the same element. If you have something with a different atomic number, then they're going to be completely two different elements. But the same element could have different masses or different mass number. So the number we see in the periodic table is what we call the relative atomic mass. So it's not the specific atomic mass of one of the isotope. So relative atomic mass is that mass which takes into account the different masses of all the isotopes that make up that element. So this is the relative atomic mass that which is the average mass of certain atoms, taking into account the different masses and abundances of all the isotopes that make up that element. So many elements can exist as a number of different isotopes, and in nature they have fixed proportion in existence, fixed abundance. And in the periodic table, instead of referring to the atomic mass to one of these isotopes, we refer to the relative atomic mass to take into account that there are different isotopes for the same element. So how can we calculate the relative atomic mass? We can calculate it using this equation. So relative atomic mass, which we refer to as AR, equals the percentage of isotope A, if we are considering that there are two isotopes for the same elements, isotope A and isotope B. So the percentage of isotope A times the mass of that isotope plus the percentage of isotope B times the mass of isotope B divided by 100. So if you do use this equation, you can find the relative atomic mass of uh, um, a certain atom. So let's have an example how to do this calculation. So let's find the relative atomic mass of chlorine. So chlorine has two isotopes. So chlorine 35 and chlorine 37. The relative mass of these is chlorine 35 is 34.969, and the the mass of the chlorine 37 is 36.966. The abundance of chlorine 35 is 75.8%, and the chlorine 37 is 24.20 or 0.2%. So let's use this number and this equation to calculate the relative atomic mass for chlorine. So chlorine, the symbol for chlorine is Cl. So this is going to be the relative abundance of the first isotope. So this is 75.8 times its mass, which is 34.969, plus the relative abundance of the other one, the other isotope, which is 24.20 times its mass, which is 36.966 divided by 100. If you do your calculation, you're going to find that the relative atomic mass of chlorine is actually 35.45. So in the periodic table, under chlorine, you're going to find this atomic mass, and you're not going to find it as 35 or 37. So this is called the relative atomic mass. If you are given any isotope, any element, even if it has more than two isotopes, you can simply use this equation to calculate it. So if you even have a third isotope, you're still going to add it. So plus percentage of isotope 3, of abundance of isotope C, times the mass of the isotope C, and carry on and so on. So it doesn't matter how many isotopes there are, you can use this equation and you just need to include all the different isotopes.